Hello there. Today we're going to talk about another type of data structure called a queue. A queue is usually related also with another data structure called stacks. You can see in a previous video that I've posted, but we're going to look at the queues today. So stacks and queues go together. And the idea for a queue is that you have a collection or a list of things, and this time the order, again, with the order matters, and we're going to say whatever the first item in the list is also the first out. So we use the abbreviation FIFO. A good way to visualize a queue is standing in line for something. And as you stand in line, first come, first serve is how it goes. So here, the first person at what I'm assuming is an ATM, that person can do the transaction, and then the next person, the next person, the next person. So if you're last in line, in this case over the far left, you will be the last person in the queue. There's no way to jump forward or backwards in this. The queue comes from the whole collection interface. We should be familiar with the ArrayList class coming from the list interface, which comes from the collection interface. And we have a lot of those methods: add, get, remove, empty, some different things there, set, different ones. Where here we're going to look on the right side and we're going to use just the queue interface. So the collection interface, the queue interface is a little different from the collections, or uses part of it. And ultimately we're going to implement the linked list class is what we're going to actually use. And the linked list class is partially a list and a queue. That's from a different lesson for a linked list, but it's another type of list. But with a linked list, you're limited to, you can't find anything directly in the list. You can always start at the head, and then you have to iterate through the entire list itself. So anytime you need to look for like the fifth element, like in an array list, you can do that simply by calling ArrayList.get sub5 or sub4, whichever one you want to, and you can get that element. In a linked list, you really can't do that, and it takes time to have to find those things every single time. You have to go through the entire list. But with a queue, we don't need to go through an entire list because we're always going to start at the very first thing. If you understand stacks, the idea of a stack, a quick review of that one, that is, we call it a LIFO, where it's the last thing in and the first thing comes out. So here, if you're looking at a driveway of the cars, if I needed to get this silver car here in the back that's closest to the garage, I can't just pull that car out and leave. You have to take the last thing that went into this stack or this line of cars, the blue car here, you will have to pull that car out. Then you can pull out the silver car, and then the blue one can go back in. So that's the idea of a stack, where the last object put into the stack is the first thing that comes out. And that is the rule. With a queue, the queue is the opposite way, where the first thing that puts into the queue is the first thing that comes out. And it's always going to be in that order. And when you know you're always looking at the first thing and only dealing with that first thing, that's the time you want to use a queue as your data structure in order to get a lot of different things done. Here's a quick look at the Oracle's description of the methods in the queue interface that we're going to be focusing on using. You have the add method, which just puts anything in there, just like an array list. It adds the element to the end of the queue or the end of the object. Element just retrieves it, so you can find the element. It's kind of like using the get method, but it only gets the thing at the beginning. Offer is what puts things in there too. It also, similar to add, there's different reasons for those. You have peek. Peek, which just looks at but doesn't remove. Same thing as pull, pull is the same thing as element, and then remove takes things out. You have a couple methods that repeat themselves. Sometimes they throw errors, other times they don't. When you know, and why use them differently. So when you know that something is guaranteed to work, you don't need to check for the error. You can just call whichever thing you need to, such as element. And then other times when there might be an error, you're not sure if something's actually in the queue or not, you might need to call the other method. We'll focus on a couple of those as the demonstration for today. So here's a basic queue example. Just like any collections, like an array list or a stack or anything else, is that we're going to use the brackets, the little chevrons, to help do this here too. So we'll start it off, we'll just call it a queue. Queue just stands for a line in general terms anyway. And it's going to come from that linked list class is how we set it up. On the right side, you can kind of see what the answers are going to be as we build and run this thing. So with a queue, similar to an array list, let's just put some elements in there to see how the data structure gets built. So the queue.add, we can put anything you want to. Here we have an array list of strings, so let's just add certain animals in there. So let's add a dog and a cat, similar type things, kind of the classic ones here too. And then we can print this out. So because it's a data structure, it's an object, we don't need to define our toString method, it's already there. And so you run this and it'll print out, you can see on the right side, it'll print out dog and then cat. If we wanted to add a few more animals, oops, I can't spell today, I apologize. It's been a long week, I'm recording this on a Friday. And let's just add bird. Let's add another animal here, sloth, which is my spirit animal. Or at least I want it to be my spirit animal, even if it's not. And add, and let's find some of the little short ones that we can spell here. So let's add a koala. Now, when we print these out, just like adding them to a typical array list or things, these elements, these objects always get added to the end of the queue. So it should be in order: dog, cat, bird, sloth, and koala, just like the order that we put those into. So that's a basic part, just calling the add method. You guys should be comfortable with using that one. Now, let's look at everything. Let's see the difference between peek and remove. These are the big ones that I'll encourage you to use, partially because we already know what's going to happen. You can kind of check to see if it is empty or not for other elements right there too. So peek, just like with the stack, the peek method looks at everything but doesn't actually remove the first element. So you can just look to see what it is. Other times you can take it off, and it's nice to have those options, because with a queue, if you ever take the thing off, you can't ever put it back. You're going to put it back at the end. You can't put it back in the front here. So peek will look at the first thing. In this case, it should be a dog, and we see dog gets printed out on the right side. So we are lucky there. And just to show you that things don't go away, so when we print the entire queue again, all 5 objects should be there. Let's run it, see how it looks. Okay, good. When we run it, the dog is still there. So that just kind of shows you the peek method only looks and tells you, returns what the object is, but doesn't actually take it off. In order to take it off, we're just going to use the remove method. In the array list class, there's also a remove method where you pass in the parameter of where the element typically was, the index of the element. In this case, the way the queue works, which makes it simpler, is that we always remove it from the head of the whole thing, or the very first element gets removed. Because it's the same thing, we don't need to have a parameter for this one. So let's look at the removal, do a couple of examples with that one, and we'll go from there here too. So string animal removed. Oops, dot remove. Okay. So the remove method, it'll always return some sort of element for you, but you can also, that's why the E is there for the collection or for the generic. And then but you can also treat it like a void method and just call remove if you needed to, and not actually have it assigned to another value for that. So let's just print this out. Let's make sure we know what got removed. So the first element, the first item should be removed from it. So this should be a dog, and that's what should be printed out. Good, the dog was the first thing that's removed. Now when we print out the entire list, let's just make sure it was taken off. The dog is taken out of our queue at this point. And so here you can see now we only have 4 elements in there, and cat is now the very first thing. So real similar to the remove method in the array list class. If you're comfortable with that one, we said remove sub-0, it'll take the first thing off. We can remove lots of different things. So here, oops. So this one, instead of just calling the remove method separately, we can do it directly either in a print line statement or just have it being called and removed. So we can see that we remove the cat. Oops. Okay, and again, just to show you, make sure the cat, since that was removed and printed out, there should be 3 things left: the bird, the sloth, and the koala, so we're good. And then instead of having to return it and see that object, you can just call the remove method you want if you wanted to. So q.remove, q.remove. Let's see how many more things we have. So if I take out 2 more, we should just be left with the koala left into the array list, which we do. We can add a few more things if you needed to, so you can always go back and q.add. Let's add a couple more animals that we can think of. Let's go duck. Add. Let's add a shark or a fish. Try to keep it in the order that you saw earlier. And let's add a shark. And definitely misspelled Q here. So we run this, so now as we're adding more things, they should be added after the koala in the order that we did. So we should see koala, duck, fish, and shark. Yes, we do. Same order in which we added them there, so that's good. And some other things too. The last part, it's in case you do need to iterate through everything. You can use an iterator. You could use the iterator class, or you can use the classic for each loop, which allows us to iterate through everything. So whatever object I'm dealing with, in this case a string, so let's make a temporary string called animal. And as that goes through my entire list, so for each animal in the queue, we can get it, use it, whatever we have to for things here too. Oops, I don't want to print out queue every single time. I want to print out the animal. So using a for each loop, that'll iterate through. We get the temporary copy of the animal or the value for that, and we can print those things out. We can manipulate them, add them, whatever way you want to. But by using the for each loop, since we didn't call the remove method, nothing is gone. So one last final part, just to show you that it works, is when we print out the queue, even though I've iterated through everything, I never modified or removed. So we still have the whole list of those things. That's a basic idea of a queue. It goes through, think about it like waiting in line, and anytime you're adding things, everybody gets added to the end of the line. As you are removing, you always remove, there's always the first customer, the first person, the first thing in line, that's what gets taken. And then the peek method that allows you to look to see what the object is, but doesn't actually take it away, but remove will remove the object. Both peek and remove return what those values are. So enjoy working with the queues as you work on a couple programs.